should be coming on. Okay, we're going over questions over homework number, what number was this? 15? 15, yes? You should all have that on the top of your paper that this is number 15. All right, and so we're looking at number 60, and 60 is like a function like f of x is... Yes?
Yeah.
All right. So I have a question. How did you do 59?
You showed how we do.
I made two equations.
Okay. What is the right? Is this negative 2?
That's not.
For x is?
Less than or equal to negative 1.
Is this the or equal to or not, or?
What?
It really doesn't matter. Okay. So first of all, we're going to look at this one. Now, did we do examples, an example like this in class?
No.
Yes, we did.
Well,
Yes, we did. Was it a piecewise function?
Yeah.
Were you looking for A or A and B?
A.
Or A and B?
Yeah.
Yes, you were. And were you trying to make the function continuous?
Yeah.
Yes, and did I post a video of that? Yes, so could you have rewatched it? These are solved exactly the same way that one is. Okay? You have to be able to take knowledge or notes that you get and apply it to problems that may look slightly different, but are asking you to do the same thing. These two are done exactly the same way. We want to make this function what? We want to make sure that it's what? Continuous. Okay? So, what did we talk about when we solved the other ones? In order to make this a continuous function, what has to happen with all of these parts? They have to line up. Okay, the y values of the graphs have to line up. But what are the numbers where they may not line up? Negative 1 and 3. It just so happens that there's 2 places instead of 1 where they may not line up. But does that make it a problem that we have to skip? No, I should not have to show you how to do every problem for you to be able to figure it out. Okay, we're using exactly the same thing. We want these to have the same y values at this value and this value. Now, you're not going to set all of these. What did we do with our functions? When there was 2 of them, what did we do with them? Set them equal. Okay, so there's 3 of them. Guess what? We can't deal with 3. So take 2 of them. So these 2 have to be equal, right? Have to be equal. So 2 has to equal ax plus b when x is what? How do you know it's negative 1 and not 3? Don't both of these 2 parts only share the negative 1? Yes. Is that any different than the example we did in class? No, it's not. It's the same idea. So now we've got these 2 equations have to be equal to each other when x is what?
3.
Okay. And what's our goal in the end of this? To find A and B. All right, so if I do, what can I do with this part now?
Just plug
Okay, I want specific.
2 is equal to negative A plus B.
Good, so you're plugging negative 1 in place of the x. Okay, can you solve that for A or B? Yeah, I can. B is equal to what? B is equal to 2 plus A, yes?
Yep.
Okay, but can I figure out exactly what number B is or A is? No. Okay, that's fine. Guess what? Over here, what can I do? 3a plus b equals negative 2. Okay, so now I have another equation, it has a and b. I have this equation over here, it has a and b. In Algebra 2, you spend half your year solving these kind of problems. Solving a system of equations. What can you do?
Plug in B or
What's going to replace this B? 2 plus A, substitution. Replace that B with 2 plus A. 3A plus A is 4A. Subtract 2. Divide by 4. What's A? If A is negative 1, what's B? 1. So B is 1, A is negative 1. Okay? So, this one looks really hard, like, man, we must need to learn something totally new to do this. No. These two, in order for this whole function to be continuous, what has to happen with these two parts? They have to be equal. So x squared minus a squared over x minus a has to equal 8 when x equals what? A. All right, so we are going to run into a little problem here when we go to plug a in for x. So my goal, if I could plug a in for x and then get a by itself, wouldn't I know what a is? So when I plug a in for x, I get a squared minus a squared, which is kind of a bad deal because that's 0. And I get 0 on the bottom, and so what do I get? I get 0 equals 8. Okay, doesn't work out. I can't solve for a. Okay? Well, what can I do? Because I need to figure out, well, I want this to be a continuous function. Okay, so here's what I'm going to do. Instead of just plugging a in for x, I'm going to take the limit as x goes to a of this function. Because obviously, when I plug a is a place where this function is not continuous. Would you agree? Okay, where is this function not continuous? When the bottom equals 0, when x equals a. Okay, so that's why this function can't equal a. We just need to figure out what a is. So I'm going to find the limit because I would hope that both of the lines are going to the same place here. All right? So how could I find this limit knowing that I can't just substitute the a in? Factor the top. Okay, so how does the top factor? X minus a, x plus a. The x minus a's cancel, so really I'm just finding the limit as x goes to a of x plus a. So now I'm just finding the limit as x goes to a of x plus a equals 8. So this side, now I can just plug a in. So what's a plus a? 2a. And what does a equal now? 4. All right, other questions? So you all got that secant problem, huh? That's good. Glad you did. Maybe there's more than one of those.
I would do 71.
It would help if I got on the right page. Okay, 71. Oh yeah, okay. So problem 71. I want to know, what do I want to know about this function? I want to name all the what? All the intervals where it's continuous. So how many of you already know that secant is not continuous without looking at a graph? Every single hand in here should go up. Do you know why? You were required to take pre-calculus before you took this class. And in pre-calculus you learned what all the graphs of all the trig functions look like. And you should know that secant, cosecant, and tangent and cotangent are not continuous functions. That they have little swoopy things and little U's and hills. Okay? So thankfully they give you the graph already. And you need to name all the places that it is continuous. And so the graph looks like this. They don't really have all of it, but it has asymptotes here and here. And you should have been really able to graph this. You know, it's going to have these U things like and hills like this. And this is all they really give you. And so tell me where this picture isn't continuous. At x equals -2 and x equals, okay, but just to name that, that's wrong. Because tell me about this graph. Is this the whole graph? It continues. So over here, guess what? There's a U. And then at 10, there's another break, and it goes down here. And there's another, it looks like this all the way. So these places of discontinuity happen constantly, forever and ever. You can't list them all. Okay, there is a pattern though, and you learned how to deal with patterns and write the patterns into equations back in pre-calc. So you know for sure that there are two of them at -2 and 2, and actually you should realize, okay, that this pi x over 4, the pi over 4 in front of the x here tells you that the normal secant of x function, which has a period length of 2 pi, okay, that because of this pi over 4 in front of the x, that the period length is going to change. And it's going to change to 2 pi divided by b, whatever that number is, divide by pi over 4, multiply by the reciprocal, the pi's will cancel, you'll get 2 times 4, or 8. So the period length of this function is 8. Alright, so like from here to here is one period of the secant function. So you should then, know instead of the marks being at like pi and pi over 2 and pi over, pi and 3 pi over 2, that it changes to numbers along here. Okay, now you didn't have to do that because thankfully they gave you the graph. All you have to be able to do is more than just name these two as places of discontinuity. So I'm going to use a formula. It's called the sequence formula. The formula for the nth term of an arithmetic sequence. An arithmetic sequence is where you're just adding the same number each time. What number am I adding each time to get to the next term? I'm adding 4. The common difference is 4. And I could pick any of these as a starting number. So the nth term is the first term plus the common difference times n minus 1. So I want to take this pattern of numbers, -6, comma -2, comma 2, comma 6, comma 10, comma 14, comma ... This pattern of all the places where this is not continuous, and I want to write it in a short little equation. And so I can use this formula from pre-calc to do that. And that's how they get the answer out of the back. We'll get a different one. You could just think of this on your own, okay? If I start at 2, if 2 is my first number, okay, well, how do I get to the next number? Plus 4, but times, I could just do n, right? I don't even have to use that. I could just say 4 times, all multiples of 4. So I'm taking 2, and isn't 4 times 1 going to give you 6? If n is 1, and then what if n is 2, what do you get? 10. And if n is -1, what do you get? -2. So this little formula is, they just, kind of made that up from the problems. If you use this, you'll get 2 plus 4 times n minus 1. Distribute the 4. Combine like terms, you'll get 4n minus 2. Is that the same as this? No, it's not. But if you put 1 in, what do you get? 4 times 1 minus 2 is 2. If you put 2 in, you get, if you put 3 in, you get, if you put 0 in, you get, okay? So either of these works for naming all of these places. So it is continuous everywhere except where x equals those values. All right, any of the problems from 75 on?